Good morning dear friends. Today we will discuss classification of ordinary point, singular point, regular singular point and irregular singular point. For that we need to understand the definition of analytic function. A function f of x defined on an open interval containing the point x equal to x0 is called the analytic at x0 if its Taylor series summation n equal to 0 to infinity and derivative of f at x0 upon x factorial into x minus x0 exists. In short, a function f of x is said to be analytic at x equal to x0 if we find the Taylor series at x0. Note 1. All polynomial, trigonometric, hyperbolic function are analytic as we find the Taylor series of it. Most important, a rational function is analytic except at those values of x at which its denominator is 0. Let us consider example 1. Here f of x equal to x upon x minus 1. Its denominator is x minus 1 and it becomes 0 at x equal to 1. So we can say that a function f of x is analytic everywhere except x equal to 1. Same example number 2. Look at the example. Here numerator is x plus 3, denominator is x minus 1. Once again, this is not defined at x equal to 1 because if you put x equal to 1 then denominator is become 0. So f of x is analytic everywhere except at x equal to 1. In example number 3, denominator is x minus 3 and it becomes 0 if x equal to 3. So f of x is analytic everywhere except at x equal to 3. In short, for analyticity we have to find out denominator, and for denominator when it becomes 0, at that point the given function is not analytic ordinary point. A point x0 is called an ordinary point of equation y double dash plus p of x y dash plus q of x y equal to 0 if both px and qx are analytic at x equal to 0. Singular point, a point which is not ordinary point is called the singular point. A point x0 is called the singular point of equation y double dash plus p of x y dash plus q of x y equal to 0 if either px or qx or both are not analytic at x equal to 0. Regular singular point. A singular point x0 is called the regular singular point of differential equation y double dash plus p of x y dash plus q of x y equal to 0 if both x minus x0 into px and x minus x0 square qx are analytic at x equal to 0. Irregular singular point. Our singular point x0 is called an irregular singular point if either x minus x0 px or x minus x0 square qx or both are not analytic at x equal to 0. Let us understand by examples. Classify ordinary point, singular point, regular singular point or irregular singular point for the following differential equation. Consider example 1. Example 1 is x cube x minus 1 y double dash plus 3 into x minus y dash plus 7xy is equal to 0. Solution. Convert given equation 1 in the standard form of differential equation y double dash plus p of x y dash plus q of x y equal to 0. Here the coefficient of y double dash is 1. So divide differential equation 1 by x cube into x minus 1. So look at here, we have y double dash plus 3 upon x minus 1 upon x cube x minus 1 y dash plus 7x upon x cube x minus 1 y equal to 0. Here we divide it by coefficient of y double dash. Now by simplification, y double dash as it is, x minus 1 cancel out, so 3 upon x cube y dash plus here x will be cancel out, so 7 upon x square x minus 1 y equal to 0. So we got standard form. Now compare above equation with standard form, y double dash as it is, we got p of x is equal to 3 upon x cube and q of x is equal to 7 upon x square into x minus 1. So according to definition of analytic function 3 upon x cube, here denominator is x cube, so it is not defined for x equal to 0. So for p of x is not analytic at x equal to 0 and q of x, look at here, 7 upon x square x minus 1. So here it is not defined for x equal to 0 and x equal to 1. So q of x is not analytic at x0 equal to 0 and x equal to 1. So we can say that using definition, 0 and 1 are singular point of given differential equation 1. So here x equal to 0 and x equal to 1 are singular points of equation 1. For singular point x0 equal to 0. Now we are checking whether the singular point is regular singular point or irregular singular point. So consider x minus x0 into px. Here we take x0 equal to 0. So x as it is, x0 equal to 0, p of x is nothing but 3 upon x cube. So here x will be cut down, so we got 3 upon x square. So which is not analytic at x0 equal to 0 because it is not defined for x equal to 0. So there is no need to check second option because according to definition, if one of them is not analytic, then it is called a irregular singular point. So 0 is irregular singular point of given differential equation 1. Now for singular point x0 equal to 1. So consider x minus x0 into p of x. So is equal to x, x0 is 1 minus 1, p of x is 3 upon x cube. So 3 into x minus 1 upon x square. Now look at here we are checking for x equal to 1. If you put value of x equal to 1, then denominator become 1. So there is no problem for analyticity. So here we can say that this function is analytic at x0 equal to 1. Noted that it is analytic at x0 equal to 1. We are not talking about x equal to 0. We are talking about for x0 is equal to 1. So first step is clear. So let us go for second steps. Consider x minus x0 square into q of x. According to definition, we multiply x minus x0 square. So x0 is 1. So x minus 1 square into 7 upon x square into x minus 1. So 7 into x minus 1 upon x square. So which is analytic at x0 equal to 1. So therefore it clear both the steps. So we can say that 1 is regular singular points of given differential equation 1. Conclusion. Hence the set of ordinary point of differential equation is r minus 0 1 because two singular points remaining are ordinary points according to definitions. The set of singular points of differential equation is 0 and 1. The set of regular singular points of differential equation 1 is 1 and the set of irregular singular points of differential equation is 0. Now let us consider second example. So from second example, convert the given differential equation in the standard form. So for standard form we have to divide by its coefficient of y double dash. So we divide equation 1 by x square minus 1. So y double dash plus x upon x square minus 1 y dash plus minus 1 upon x square minus 1 y equal to 0. Compare above equation with standard form. So we have the value of p of x equal to x upon x square minus 1 and q of x equal to minus 1 upon x square minus 1. So according to the definition of analytic function, p of x is equal to x upon x square minus 1 is not analytic at x equal to 1 and minus 1 because here denominator is x square minus 1 and if we put x square minus 1 equal to 0, we got x equal to plus or minus 1. So in short, p of x become undefined for x equal to 1 as well minus 1. And similarly, this is true for also q of x. So we can say that 1 and minus 1 are singular point of given differential equation 1. Remaining are ordinary points. So here x equal to 1 and x equal to minus 1 are singular point of the equation 1s. Now let us check for regular singular point and irregular singular points. So for singular point x0 equal to 1, step 1, consider x minus x0 into p of x. X minus x0 is 1, p of x is x upon x square minus 1, its factor is x minus 1, x plus 1. So x minus 1 will cancel out, so we got x upon x plus 1. Now this is defined for x equal to 1, so which is analytic at x0 equal to 1. Now consider x minus x0 square into q of x. So x minus 1 square minus 1 upon x square minus 1. So x minus 1 will cancel out, we remaining with x plus 1. So minus 1 into x minus 1 upon x plus 1, and it is defined for x0 equal to 1. If you put the value of x equal to 1, we got 0, so it is defined. So which is analytic x0 equal to 1. So from both the steps, we can say that these both are analytic at x0 equal to 1. Therefore, x0 equal to 1 is regular singular points of given differential equation. Similarly, if we put x0 equal to minus 1, we got same result. So we can say that x0 equal to minus 1 is regular singular point of given differential equation 1. Hence, the set of ordinary points of differential equation 1 is r minus 1 minus 1. The set of singular points of differential equation 1 is 1 minus 1. The set of regular singular point of differential equation 1 is 1 minus 1. Look at here, all singular points are regular singular points. The set of irregular singular points of differential equation 1 is empty. Thank you.